Sheet up here looks a little bit different because Miss Cronky and I added in some more specifications, but I didn't really want to redo all of my work. So I'll point things out that are on yours that aren't on mine. So the first thing I want to point out, you gotta name your roller coaster, okay? You can be lame like me, the polynomial thriller, okay? That's kind of lame. You could be exciting, okay? You can pick a theme. I don't care, okay? Just name it something, okay? Jacob's roller coaster. Couple facts about roller coasters on here for you. The tallest roller coaster in North America has a height of 456 feet, and it lasts 50 seconds. So when you're trying to make your roller coaster somewhat realistic, and I'll tell you what I mean by somewhat, okay? You probably shouldn't have it go above 450 feet, okay? A 1,000-foot roller coaster is not acceptable, okay? Now, there will be a requirement that you create your roller coaster to go underneath the ground in a tunnel. The most that you would go underneath the ground, the Haunted Mine Drop in Colorado drops riders 110 feet. And any subway station, the deepest one is 180 feet. Okay, so just keep that in mind. So I am asking you to build a roller coaster. Here are my first set of requirements for your roller coaster, and this is how I'm going to grade you. You need to have a polynomial of at least 6th degree. It can be higher, but minimum 6th degree. My next one, you must have at least 5 unique zeros. Mrs. Holman, you just told me 6th degree polynomial. Okay, you better have one with multiplicity of 2. You must include at least 1 zero with even multiplicity. Whether it's 2 or 4, I don't care, but it needs to have even multiplicity. Yes. Okay. Your roller coaster can start at any height, but the x-axis is the ground level. It must dive below the ground into a tunnel at least once. Okay, that should be pretty easy to do. And the x-axis represents time, but your ride begins at time equals 0. Okay, so let's say you have a 0 here and a 0 here, to where your polynomial looks like this. Time begins at 0, which means the only part that matters for your ride is that. Okay, well, if you want to start above and dip down the very first thing, that's fine. You can have a -0, but it's not going to be a part of the domain for your roller coaster because time has to begin at 0. Does that make sense? Yes?
Do the 5 unique zeros have to be like on positive x's? No. Okay.
I just need you to get the shape that you want, but anything negative just wouldn't be a part of the domain of the ride. Yes?
So it doesn't need to start and end at the same height. Like you can start it really high and get the
Correct. Okay. Yeah, you can start at any height. Probably, if you don't end at the ground, you would want to like draw something in, but I would just suggest ending at the ground, right? People just get off your ride and go. Okay. So what you're going to do is you're going to figure out what your zeros are, write the factors, okay? But here I have a spot for you to define your x and y variables. It may not be as simple as x is time in seconds and y is height in feet, okay? If you choose zeros of like 20, 30, and 60 to represent seconds, your polynomial is going to stretch really, 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 really tall. So you could just pick a leading coefficient to multiply by to shrink it down, okay? Or you have the option of picking zeros like I did of like 0, 1, 2, 3, 4, 5, 6, 7, and I just say, well, every unit represents 10 seconds, and now my ride is 70 seconds long instead of 7. Okay? Or maybe your roller coaster, your highest point is 5, so you say, okay, every unit represents 10 feet, so my roller coaster goes up 50 feet in the ground, off the ground. You see what I mean? Okay? So don't feel that, first of all, you have to use my scale, okay? Don't feel that you have to stay with small numbers. You can have every unit is 1 second, and you can pick zeros from 0 to 30 or 0 to 50 or whatever. But your ride should last somewhere around a minute, okay? It can be a little less, it can be a little more, but probably no longer than 2 minutes. Have you ever been on a roller coaster that was more than 2 minutes? Okay. Which one? No?
No.
Okay. All right. So, how do you figure out what your roller coaster is going to look like? Everybody's is going to be different, right? I'll show you. This is the one that I built and that I'm going to reference during our little discussion here. But basically, you need to start picking zeros, okay? You can use your graphing calculator, or what I find very helpful is this website, desmos.com. Okay? You can just start punching in zeros, or excuse me, factors. X minus 1. I want x minus 3 to happen twice. And then x minus 5. Okay? So I start to get a pretty cool shape, right? Like, all right, well, I kind of like that, but I would rather have these guys on the other side of the x-axis, so I can put a negative, and now it flips them over, okay? Now, this isn't meeting my specifications. I'm just showing you what happens, okay? Well, maybe I don't want them to stretch that high. Maybe this is higher than I'd like, okay? What kind of number should I put out in front if I want to shrink it down? A fraction less than 1, okay? So now I have shrunk my roller coaster down, okay? So my suggestion to you would be to just start playing around with the factors before you decide to write them down. Play around in Desmos until you get what you like, and then write some things down, okay? But you may have to play around with that leading coefficient until you get like the heights and the distances that you want. Okay, let's go back to my PDF here. Okay, now you are more than welcome to have more than 5 zeros, and you're more than welcome to have a polynomial of greater than 6. Okay, just keep in mind you're going to have to multiply all of your factors out. Okay, so the more factors you write down, the more multiplying you have to do. My bare minimum is 6, right? Now, some of you are like, oh my gosh, that's a lot of work. Okay, this is probably going to be the more time-consuming part of your project, but if you have patience and you're very organized with your work, it'll be fine. Okay, I was able to squish my work into the space provided, but if you are not able to, just put it on a nice sheet of paper and attach it, and that's perfectly fine. Okay, now, some of you may be thinking, Mrs. Holman, you don't have an answer key for this. How do you know if I'm right? How do I know if I'm right? What would be a nice way to check your answer to make sure you're turning in correct work? Plug it into the Desmos thing. If I graph this polynomial right here and this polynomial right here, they should be the same graph. If they are not, you probably messed up in your work somewhere and you need to go back and fix it. Okay? If you do decide to have a leading coefficient that is not positive 1, I would multiply that very last. Okay, you can see that I multiplied everything together and then I distributed that negative 1/2 through. Otherwise, I'm working with fractions the whole time. Okay, it's a lot easier to keep track of your work if you wait to multiply that leading coefficient through very left. Okay. Number 5 is just basically asking for the ending behaviors of the graph. Use the leading coefficient test. Give me the notation, but then explain to me how you knew that. All right. Now, obviously, your roller coaster does not have this behavior. It's the polynomial itself. But in my situation, I had a negative leading coefficient, so the right side was going to fall. So I literally wrote that. Since it was an even degree, I knew the left would also fall. Okay, I want you to give me the notation and the explanation of how you knew that was the answer. Okay, number 6, this is the best part. And you'll see that I have a lot more details on number 6 than I do up here. So look at those details as I explain this to you. First of all, it's going to be on a piece of graph paper. I have graph paper for you right here in this bin. Okay, there's plenty of them for you. Notice how my roller coaster fills the page. It is not teeny tiny in the corner. It literally fills up the entire page. I want it to be like, yes, this is my polynomial. Okay, you are proud of this polynomial. Okay, so I have my title. I have my x and y axis, and I have them labeled. I have them labeled as time, 1 unit is 10 seconds, and height in feet, so I know what I'm looking at. Okay? It is not done in pencil, it is done in some sort of non-pencil item. Okay, I don't want to say pen because you may use markers of some sort. Okay? I also have labeled my absolute minimum point and my absolute maximum point. Okay? Okay, those are very strange numbers. How did you figure that out? There are 2 ways you can do this. I taught you how to do it in your graphing calculator. But if you're already using Desmos, I'm telling you, Desmos is just wonderful. Okay, do you notice how if I touch on the polynomial, all of these points are highlighted? Minimums and maximums are highlighted. So if you just hover over the point, it'll tell you the maximum. Isn't that pretty cool? Okay. I'll tell you in a minute why I want the minimums and maximums, but I do want them labeled on your graph. Let's go back to that graph. Okay. I want them labeled on your graph. So here's my minimum and here's my maximum. Now, this is bare minimum requirements right here. Okay. You are welcome to color this. You are welcome to draw little cars and people riding on it. You are welcome to add to the creativity of the project, or you can turn in something else like this. Okay? I'm not requiring any colorfulness. This is my bare minimum, but some of you like to be creative, and I will encourage that opportunity. Okay, but don't feel like you have to. Also, I was going to point something out. I'm not thinking of it right now. Okay. We'll come back to the graph in a little bit. Maybe. Oh, here we go. All right. So then, a lot of your points really are coming from following my directions and answering correctly. Okay, this is a 50-point grade in the formative category, which is the biggest formative grade you've had this semester. Okay, it is formative, but it's like double, even triple the size of some of your problem sets. Does that make sense? Okay. Like your problem sets have been like 12 points and 20 points, and this is 50. Okay. So number 7, state the practical domain of your graph, the actual ride. I know that the domain of a polynomial is all real numbers. That's not what I'm asking for. I'm asking for the domain of your ride. So since my ride begins, well, all of our rides begin at time is 0. My ride ends at 7, 0 to 7 is my domain. Okay? The range, this is where your minimum and maximum help you. Okay? Minimum point, maximum point, that's the range of your roller coaster ride. Okay?
So, minimum first.
Yeah. Questions you have so far? Okay, this is a chance for you to be creative, okay? And like I said, as long as you follow my directions, you're getting a majority of the points, okay? You should be proud of the work you complete. It says that on this back side, okay? If you were to show people that you really care about this project, I would want you to be proud to show them, like put it on the refrigerator proud, okay? I don't want you to like hand it in and say, don't show my mom, like, no, you would be like, yeah, show this off, okay? I want you to be proud of your work. So, don't wait till Sunday night to do it, okay? Because it's probably gonna take a couple hours anyway. I don't know if you wanna wait till Sunday night. But this is what I'll do. So the rest of today, you can either work, I'm going to hand out the review regardless. You can work on the review or you can start messing around with zeros and factors. Tomorrow, we have 50 minutes in class. Probably 45 of those will be just dedicated to work time. You can work on project or review. But our test is on Friday, and this project is due Monday. Okay? If I were you, I would not wait till the weekend to begin the project. However, I realize that's not a realistic possibility for some of you. I just want you to keep in mind, if you start it today or tomorrow, you can at least ask me a question in class if you have one. Otherwise, if you start it over the weekend, your only option is email, okay? I probably won't be around. I will not be available Saturday to email back. I'd be around Sunday to email back, but then I go to bed early. So if you stay up till midnight working on your project, I'm sleeping away and I'm not going to be able to answer your question. Okay? So just keep those things in mind when you're planning your time. You've done a lot of time management, discussion, and Titan time. Okay, keep that in mind with this project. Well,
I don't like the way it just puts us up a long time. It's just like, just work.
It's kind of like advisory. We're given things to do with you, and sometimes. So I'm going to hand out the review. I did record this discussion that we had so that it's relived.